All right, let's explore Lewis dot symbols created by Gilbert Lewis. These symbols are going to help us represent bonding, especially between covalent molecules. So, what we need to do is focus in on the valence electrons. Those are the outermost electrons that are actually crashing into each other and doing the bonding in the first place. We don't want to look at the rest of the molecule. So in order to draw our Lewis symbols, you need to know how many valence electrons different atoms have. The good news is it's really simple because the number of valence electrons is the same as the main group it is in. So for example, if you're an element in the very first column, either hydrogen or an alkali metal, all of those atoms in the first column have one valence electron. They end in an S1, one in the outside shell. If you are an alkaline earth metal, beryllium, magnesium, calcium, strontium, you have two valence electrons. You end in an S2. We're going to skip the transition metals for right now. Most of those have two valence electrons, but we're not going to worry about those at the moment. The third column, starting with boron, aluminum, gallium, all of those atoms have three valence electrons, an S2P1 type of valence configuration. Then we go for carbon family, four valence electrons. Then the nitrogen family has five, S2P3 valence electron configuration. Then oxygen, six, the halogen family, seven, and finally the noble gases have eight. Now, make sure you understand that this is not charge. We don't use that when we're writing formulas to figure out, the crisscross for different formulas like magnesium chloride. This is valence electrons. Now, the way that we're going to go ahead and use these valence electrons is we're going to draw electrons as dots around a symbol. So let me give you an example. Let's say that I wanted to do the Lewis dot symbol for selenium right here, Se. Now what I want you to do when we're writing a Lewis dot symbol is you write the symbol down, Se, and then I want you to imagine a box, an invisible box surrounding selenium. I'm going to draw it here, but you should not draw it. Don't draw a box, but I'm going to draw it right now. Just imagine one. Now we're going to put a dot for each valence electron that we have for selenium, and we're going to put one on each side before we double up. So selenium has six valence electrons. I'm going to start on any one of these sides. It does not matter where. Here's my first dot, one. But now I don't want to double up here. At most, two can go on each side. So here's 1, 2, 3, 4. I've put one on each side. Now I've got two left to go. I can start to double up now. Now when you double up, it's important that if you have 1, 2, 3, 4, the next one stays on the line of this box. Don't put it out there. That's not on the box. This would be a no. You want to put it on the line of the box. So this is selenium with 5. I don't care where I put 6. It doesn't matter. I'm going to put 6 right here. I have 6 valence electrons. This shows me that to be full, for an element to have its octet 8 around it, selenium needs 2 more partners, and then it can have 8. Selenium is going to make 2 bonds. It has 2 openings for more things to bond to it, at least 2. So this is the Lewis dot picture for selenium. Let's get a little bit of practice. The first one I want to do is neon. If you look at neon, neon is right here on the periodic table. It has 8 valence electrons. So the Lewis dot picture for neon is we draw the symbol for neon, and we're going to put a dot on each side. 1, 2, 3, 4, and now we're going to double up. 5, 6, 7, 8. There's your Lewis dot picture for neon. Lithium. Lithium is an alkali metal in the first column. So the Lewis dot picture for lithium, Li, 1 dot. I don't care which side you put it on. The next one we have is sulfur. Sulfur is in the oxygen family with 6 valence electrons. So I'm going to draw an S, put 1 on each side before doubling up. I've got to get to 6. 1, 2, 3, 4. Now we're going to double up 5, and we're going to double up 6. Make sure those dots are equally distant to that sulfur. The next one, phosphorus in the nitrogen family. Since it's in column 5, we're going to put 5 valence electrons around phosphorus. 1, 2, 3, 4, double up. There's your 5th. Barium is our next example. Barium is an alkaline earth metal in the second column. I'm going to write its symbol down and 2 dots. Where? I don't care. I'm going to put 1 and how about 2? Just because I feel like it. Just not doubled up. Bromine. Bromine is a halogen in the 7A group family, so it gets 7 valence electrons. We draw its symbol bromine, and we're going to start 1 on each side before doubling up. We've got to get to 7. 1, 2, 3, 4, double up 5, double up 6, double up 7. There's bromine. It has a place to make 1 bond right there. Aluminum. If we look at aluminum, it's in the boron family, group 3A. It gets 3 valence electrons. 1, 2, 3. And silicon is in the carbon family, group 4A. We get 4 valence electrons for silicon. We draw the symbol Si and then 1, 2, 3, 4. All right, we're going to use those symbols to help us show both ionic and covalent bonding in the next set of videos, and I hope that helps.